I'm Tom Allen, Principal Consultant for Foresite, and this is Foresite Friday. Today's question is a very interesting one. I keep hearing about quantum computing. What is quantum computing? So we're going to get pretty theoretical today in what we're talking about. It's kind of interesting, so it's hard to wrap your head around at first, but let's talk about it. So in traditional computing, we know that we use bits, right? And a bit is binary, it's 0 or 1. So let's take a number like 0 through 9. We want to represent that number and we want a computer to guess the number. So we have a number assigned and we want the computer to guess it. So it's going to take 4 of those binary pieces. Let's say 0000. Is that it? 0001. Is that it? 0010. Is that it? And it's going to go through all those possibilities until it finds the one that's true, and it'll respond with, oh, okay, this is it. So with quantum computing, it uses what's called qubits. And a qubit is both a 0 and a 1. Now wait, how can that be? Well, let's take the example of a coin. Say you have a coin, it has a head and a tail. When you flip it in the air and it's spinning, what is it? Is it a head or a tail? It's both, right? So in the same way, qubits work, that when they're in motion, they're a 0 or a 1. They're both. They're 0 and 1. So when they stop and come to a rest point and they're observed, that's when their function is true. So take that example again. It's both a 0 and a 1, all 4 of those. So it's 0000, it's 0001, all at the same time. When it finds the truth, then it uses something called a Grover operator. Love Grover is a computer scientist who came up with an algorithm that basically allows all these quantum possibilities to then take all the ones that are false and remove them and leave only the one that's true. So all of this happens instantly. So where a computer, a standard computer, might have taken, say, a second, 2 seconds to decide what that number 7 was, a quantum computer can do it instantly. So when you think about what would be the use of this type of thing, let's look at like Google Maps. So Google Maps, you say I'm at 100 Main Street, I want to go to 712th Street. So it will map out all the possible routes, determine traffic levels, and then say, okay, here you go, here's your fastest route. Well, if it was a quantum computer, it would be able to instantly give you that, not take a couple seconds to do it, because it would have all those possibilities in its head, and it would say, which one is true, the fastest route, and boom, it would have it for you. That's a sort of minor application. The major applications are things like curing cancer and things where it can take what would take 20 years to calculate certain possibilities, it could do almost instantly. But now, what does this imply for security? So we talked about it. We had a number and it guessed it instantly. Really, when we think about encryption, that's just a bunch of randomized data that equals a comment, a sentence, a document, whatever. So if we can speed up the breaking of those encryption algorithms, that's going to be scary, right? We're not going to be able to have anything secure. And then passwords, forget it, they'll just be gone instantly. So people are concerned that when quantum computing becomes a reality where everybody has it and can have access to it, security is going to go away. Well, that's a little bit of a fatalistic approach. If you think about it, can't we use quantum computing then to create tougher algorithms or better encryption? Anything that can be used as a negative can also be used as a positive. So just like when you got your first computer, if you're older, you had maybe a 4-digit password that was all numbers, and that was adequate for that time. Now we know, and we know today, that passwords are very easily broken. So because of the advance in technology, we've had to adjust our security. And that's what we'll do with quantum computing. We will adjust our security. In fact, it may make things more secure because really, honestly, the limitations will be gone. So now we could secure things so much better. But the reality is that we don't have to worry about this for any time in the near future. Quantum computing is theoretically great, and in some cases it's actually being used, but it requires supercomputers right now, and it's not something that you could go down to Best Buy and get. And that's not going to happen for a while. They have difficulties like keeping the qubits in motion is a challenge. At some points, some types of qubits, they have to refrigerate them to keep them in motion, things like that. So while the pace of technology advancement is very fast, it probably won't be another 10 years before we see quantum computing at the level that it's going to be, where people, not scientists in labs, have access to it. That being the case, not something we have to worry about today, but again, the endless possibilities with it are amazing to think about, sometimes hard to wrap our heads around. Like I said, the ability to calculate an outcome from a certain cancer drug on cells that takes years now could be done in minutes. So think about the advancements and the benefit for mankind that could cause. So it's not something to be afraid of. It's something positive. It's a forward movement. But now you have a little bit of a primer and a little bit of knowledge about what quantum computing is and what it can be. Thank you for your question. If you'd like your question featured on a Foresite Friday, send your question to wfh@foresite.com. Thank you.